Hello everyone. So today we are back again, starting with C programming language from Headfirst book. In last session, we covered a little bit about two-dimensional character arrays, a little bit more about pointer to a character array, and some nuances of pointers. Today, first we will start with revising a little bit concept about two-dimensional arrays again, and then we will continue with the next topic, whatever is being presented in the book. So if we try to remember, we start with creating a two-dimensional array like this. And the first box, it represents basically the number of rows which you can put inside it a two-dimensional arrays. And the second will mention you the number of characters which will be contained in each row. For example, we assume there will be only 20 characters, and then we can create it, and it is an array. So we will present it like this with curly brackets, and then inside it uh, we can type anything, name1 comma name2 and name3. So this we will create a two-dimensional array, and the number of rows here is 1, 2, and 3. So the size of this specific array will be 3. So now what if we want to print something? Now how can we iterate over this using the pointers? So if we remember, whenever we create a single dimensional array, if we look here, whenever we create a single dimensional array, this ARR pointer represents the memory address block of the first character of the string. So if you write ARR, it will print the address of this P, whatever be the memory location where this P is stored, it will print the memory address of this. But what we are trying to do is we are using put, so put will automatically continue looking for the memory code until it finds a sentinel character and it prints the whole string. So, but how in two-dimensional array, how can we achieve that? What does the ARR2 represents in the two-dimensional array? So ARR2 represents the memory location of the first row. It gives us the memory location of the first row. And if we try to get the value at that specific location, it will give us the memory location of the first variable of the first character of the first row. So this will give us the memory location of n. And if we want to print it, what will be the value at n? How can we do that? We can use printf %c \n, comma, what will be the value at ARR2. And now if we execute this code, it will print n. Okay, it will print n. And then what if we want to, what if rather than only printing the first character, we want this 1, 2, 3, 4, 5, sixth character. We want this 1, 2, 3, 4, 5. We want this sixth character, but we want to print the value of this sixth character of the first row. So how can we do that? First, what we will try to do is we will try to get the memory location of the first row, and this will give us the memory location of the first row. Then we will try to get the memory location of the n, the first character of the first row. So this will give us the memory location of the first character of the first row. Then we will try to increment it by 6. Sorry, 1, 2, 3, 4, 5. We will try to increment it by 5. This will give us the memory location of the 1, and then we will try to print whatever is the value at this specific location. Okay, so now let's compile it and run it. It prints 1. You can see. Now what if we want to print the same with the third row? Okay, so first what we have to do is okay. So first what we have to do is we have to get the memory location of second row, 0, 1, 2, second row. That is clearly third row. So how can we do it? ARR will get us the memory location of the first 0th row, then we will increment by 2. So this will give us the memory location of the last row, and then we want the memory location of the first element of that specific row, and we will use star. This will give us the memory location of n. Then we have to increment it by 5, and then we want to print the value at that specific memory location. Correct? Now let's try to execute it. So you can see it prints the 3. So it is simple understanding. If you are going to, if you want to get the address of this, you can use ARR2. If you want to get the address of this specific row, you have to use ARR2 plus 1. And if you want to get the memory location of the first element, then you have to get the whatever will be the value at that specific. Whatever will be the value at that specific memory location, it will give you the value address of the first element. So this is the way how the two-dimensional arrays are structured. What is happening? The caps lock on? Yeah, sorry, caps lock was on. Undo is not working. The key bindings on this system is not correct, so that's why I paste this issue. Let me increase the size a little bit. Now I think it is better. Okay, so this was the basic thing which we discussed last time, and it is clearly evident that how can we use the pointers to iterate over the two-dimensional array. Okay, so what we can do is, let's try one more thing. If we want to iterate over these specific 1 2 3, we only want to print 1 2 3, the sixth element of each row. So if you think how can we do that, let's try to understand. For int I equal to 0, I less than 3, I plus plus, then what we can do is, we know that ARR2 holds the current memory. So if we create a pointer to a character, this is interesting. So what can we do here is, so if we create a character pointer, and then in that pointer we can store ARR2 plus I. Great. So ARR2 plus I, what is this? The point here is this ARR2 plus I will be a pointer to a, not pointer to a character, but a pointer to a array, but not a pointer to a character, but a pointer to a specific row. So rather than storing, we will store the first specific location. And here we have ARR2. And rather than using the ARR2, what we can do here is, we can store is this correct? No, it is not correct. So how can we store a pointer to a two-dimensional character? So this is basically a pointer to a character. Uh, this is the correct way. What is the initialization of character pointer from incompatible character pointer 20. Rather than I'm not sure about it. This is not correct. Initialization of pointer from incompatible pointer types. So it is pointer, the array of pointers. It is an array of pointers. Okay. That one. No, this is not invalid. Initializer pointed to a 2D array. Let's try to solve it out of the internet. Yeah, pointers. Okay, so it is saying that it's two-dimensional array. Okay, okay. And so the other one, demonstrate them, scan it, equal to AR2. It is still not correct. It is also explaining the same thing. If we are using ARR, we are pointing to this location. If we are using ARR plus 1, it will store the value at of this memory address. If you use ARR plus 2, it will store the memory of this specific block. This is what we have also discussed, but they have not written the code anywhere. So, but how can we define it if we want to store that value somewhere? Or we can increment it. I think uh, rather than using this, we created a pointer to a character and pointer to a character p plus I. So specific array, this memory block p will point to this, and p plus I will point to this, and then pointer will store the memory first. Pointer will store the address of this first. Yeah. So now what we have to do is we have to print f %c comma then. So now pointer has the uh, address of the first element. Now what we want to do it evaluate pointer plus 5. We don't have to use p, we have to use ARR2. How it is fine. Now run the code. So ignoring 1 3, the output would be 1 2 3. Okay, so it is understood that pointer we have get the address of the ARR2 will give us the address of the first row, then increment it by, right, as shown in this diagram. It is evident that ARR will store the value at ARR will be the address of the first, the value at ARR plus 1 will be the address of the first element of the second row, and that's what we are doing. So ARR plus I value at specifier will be this address, plus 1 will be address of this, plus 2 will be address of this, and then we are getting the value at that specific position, and then we are getting the value at that specific position. Okay, so it is there. So now let's move on forward to the next topic. So we understood as array versus array of pointers. It is an amazing thing which we have to discuss. Code magnets. Let's work on code magnets first. The guy is working on a new piece of code for a game. They have created a function that will display a string backward on the screen. Unfortunately, some of the fridge magnets have moved out of the place. You will help them to run a reasonable. Achha, we have to print a reverse. So let's try to reverse. Um, so we will create our function reverse, and in reverse, what we are expecting a string. And now, so we are well aware of the. And first, we have to find the length of that specific string. So as mentioned that length equal to, there is an method in st, what was the, I forgot, the package header file, and the header file was string.h, hash include string.h. So we will use that header file, and inside that header file we can use a strlen function, and we can pass there a string that will give us the length of the string. So if we try to simple, just print it out right now. Print %t comma lens, and here we are going to, what we are going to do here is change main, and let's create a string for the stream, and then we are going to pass it in the reverse. I'm going to pass this and size t. Okay, a long assignment. Long to LD. And for printf we want to include stdio.h. Okay, now it's fine. Okay, with gcc reverse.c or and then we will use our team. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it is correct. We were able to count the number of the length using strlen. Okay, so that is evident. Now what we have to do here is we have to print the element in reverse. So what we are going to do here is, for we will create a index 0 to I less than len s I. Rather than going, what we can do here is we can create I equal to len s minus 1, I greater than equal to 0, I minus minus. Okay, so what we have done is we have created, we will start from 17 and we'll go to until it is 0 and then unsigned. So we are using size. So size is unsigned, long unsigned. So unsigned will never go negative. That is the point, it will never go negative. So if we use that, will cause a problem for us. Now it is fine. It will go minus 1, and as soon as it is going minus 1, this loop will get break, and then what we will do here is we have s. S will point to the first character. Obviously, it will point to the first character, but we don't have to print the first character first. So what we will do is print f %c backslash %c comma. Then we have to use s. S will give us the location of the first, and then we will increment s by I. We will increment s by I, and for example in this scenario s will give the first address. First s plus I means 17, that will print the last element. Then it will decrement second last element, third last element, fourth last element, till it prints all of these elements. If we compile it and then execute it, okay, no problem. Then here we will groups. Okay, what we can do now is print no. Now have put this so you can see poor coders tree. So it works. Now what will be the problem if we try to use size t? So it is a long unsigned int. So if we decrement 0 by 1, it will go to its the highest positive value, and this loop will never end and it will keep on printing. So let's see. As what I think. No, it works fine. Is the long unsigned int. So unsigned int, what we can do here is if we print the value of I, what I scope is there, and have constant id comma I. Oh, sorry. So I am using I. That's why it works, because I is an int. And decrementing I. Okay, that is fine. Yes, it works. I thought that I am decrementing length, but I am not using length here. I am using I here as an argument. So I is an int and that will be fine. But if rather than I, let's assume we can try that. I use an long unsigned, because it's size underscore t. Fine. Now let's see what happened. Now this code will not work. It caused an issue because I was using a long unsigned int, and long unsigned int, when it decrements by 0, it again goes to the maximum value, and maximum value will always be greater than 0, and this loop keeps on continuing. So we were able to write a reverse code easily. Complete again and run it. This query. And it worked totally fine. I don't know how they have written this code, but our method was totally fine and we were able to print everything correctly. Now, the next thing they are discussing is array of arrays versus array of pointers. So you have seen how to use an array of arrays correctly, yeah, to store a sequence of strings. But another option is to use array of pointers. Correct, absolutely correct. So what we saw earlier here, we have used array of arrays. This is array of arrays to store a sequence of strings, but another option is we can use array of pointers, and array of pointers is like this. This is an array that store pointers. So another way to do this is we will also cap pointer to name, and we will define the length of the each string. I don't think we have to define the length of the each string. That is also not required. And for example, dog, cat, and then whatever whatever we want. Okay, so this is another way you can access the array of pointer just like you access the array of arrays. Similar, absolutely similar. So pointer to juice, puts juice 16.6, it will print, and print reverse juice 7, it will print the reverse of those. So it will work fine. But I think similar to the previous problem, we will not be able to what do we call the update this value, because it must be stored in constants. So this was it. We were able to complete the second chapter. Now we will move to the third chapter. So here, every operating system includes small tools. Small tools written in C perform specialized small tasks, such as reading and writing files or filtering data. So it is simply as we have used different utilities in, Linux operating system. For example, cat, we can use revise.c to display the contents of that specific file, and these are written in C. If you want to perform more complex tasks, you can even link several tools together, but how these are small tools built. In this chapter, you will look at building of creating small tools. You will learn how to control command line options. So how these command line options we can control. For example, this cat, I have passed the name of the file. This name of the file is being considered as command line option. So we will try to learn how we can control these command line option and how to manage streams of information and redirection. That is also important because sometimes, for example, I am passing this into, um, let's assume, grep. For example, I am passing revise and I am grepping it ARR. So this is redirection, or we can say piping, not redirection, we can say piping, and we are piping one input from one program, output of one program into input of another program, getting tooled up in no time. So small tool. A small tool is a C program that has one task and does it well. It might display the contents of a file on the screen or list the processes running on the computer, or it might display the first 10 lines of a file or send it to the printer. Most operating system comes with a whole set of small tools that you can run from the command prompt on the terminal. Sometimes when you have a big problem to solve, you can break it into a series of small problems and then write small tools for each of them. Absolutely right. Of 100 of small tools. So it is clearly mentioned here. Someone's written me a map web application and I would love to publish my route data with it. Trouble is the format of the data coming from my GPS is wrong. This is latitude, this is longitude, speed equal to 21. This is the data format that map needs. It's in JavaScript object notation or JSON. Okay, so it is basically array of key value pairs. If one smart sorry, if one small part of your program needs to convert data from one format to another, that perfect end of task you want for a small tool. Okay, just a second. Okay, who hasn't taken a code printout on a long ride only to find it soon becomes unreadable? Sure, we all have, but with a little thought, you should be able to piece together the alternate version of some code. So what it is float longitude, float latitude, character info 80 of characters, info start at 0, and then puts data like this. Then while scanf %f %79 scanf to enter more than one piece of data. Okay, so %f %79 producing give me every data up to the end of the line. Okay, comma longitude latitude info, and where is info? Acha, yes, info will give us the first and 79 end of the line. So until we press enter, equal to 3, return the number of values it was able to read. So if it returns 3, okay, if started printf \n and started equal to 1, printf latitude longitude info. Okay, so latitude info, speed equal to 21, info speed equal to 21. Okay, 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 got it. This doesn't seem something right. Take the GPS from the bike and download the data. It gets a file gps data.csv. Now data into the location. The data is downloaded into this file. The geo to JSON tool needs to read the content of CSV. Yes, yes, exactly. Then it will do it. This is not. This is that one is was a rubbish code. Don't want to write that. We want to write it actually like this. So take GPS data from the bike, download the data gps data.csv. So gps data.csv we will convert into geo to JSON. This is our tool, and we will convert into a JSON. Exactly. You can use scanf and printf to read from the keyboard and write to the display. But Toothpaste, they don't talk directly to the keyboard and display. Instead, they use standard output, input and standard output. Operating system, input and operating system, and the program runs. So this is standard input here, and this is standard output. The operating system controls how data gets in and out from the standard input and output. If you run a program from the command prompt of a terminal, the operating system will send all the keystrokes from the keyboard into standard output. If your operating system reach any data from standard output, by default it will send the data to be the display. The scanf and printf go function don't care where the data comes from or goes on, they just read and write standard input and standard output. Now this might sound like it's a complicated now. After all, why not just have a program talk directly to the keyboard on the screen? Well, there is a good reason why operating system communicate with the program using standard input and standard output. You can redirect the standard input and standard output so that they can read and write data somewhere else, such as to and from files. Okay, rather than reading, they are saying, okay, we can read directly from the keyboard and print directly to the to our standard output to our monitor. But rather than directly communicating with the keyboard and the monitor, what do they is they communicate with standard input and standard output. So standard input can be any file, and keyboard or anything which you want to read from. A standard output also can be anything. It can be a display monitor, it can be printer, it can be a file. That's why they communicate with standard input and output. You can redirect the standard input with this. This is very evident in Linux machine. For example, let me make a file, delete. Okay, so what I'm going to do here is, if I'm going to cat revise.c and grep arr in it, and then I'm going to redirect the standard input from here. So it is mentioned here. You can redirect, no, sorry, I am going to redirect the standard output. So this is used to redirect the standard output to a file called delete. And then if I'm going to print a delete, every content which was going to being printed on the standard output get redirected to the delete. So I am redirecting the standard output. So similarly you can redirect the standard input with less than sign. Okay. So now we can read the CSV data. So again, also what we can do here is, maybe we have this now, we can close it. So what it is saying that what we can do here is, we can also, for example, read something from standard input and redirect it over for any code, whatever we want. And this operator tells the operating system the standard input of the program should be connected to the GSP data.csv file instead of keyboard. So if we are reading something from this standard input, rather than reading from the standard input, we must read from the GPS data.csv. Correct. So now you can send the program data output.json, and then the output.json will be like this. Okay, this was amazing. So let's try to implement it. So first, let's try to write int main and use stdio.h, stdlib.h, and public.h. So this is fine. And then what we have is, we have to read something from standard input. And first, let's try to create an array of characters, and that would be the let's first create login long lat. Okay, is it correct? If I just remember, how can we do it in the same line? And then info. Okay, info. And let's assume it is only 80 characters long. Then what we can do here is, and there would be some sort of opt. So okay, so how we are going to print it? We can use printer directly to print it out. So we can use print f and printf uh, data colon backslash n. This is fine. Data colon backslash n. Okay. Now what we have to do is we have to create a while loop and we have to scan until. First we have to scan longitude, then we have to scan latitude, and then we have to scan um, the info which is being sent until we, and they have mentioned also until it for example until we encountered a backslash n. So I'm not sure about it. Oh sorry, this was not a, was a float. 9% is until a backslash n is encountered. Am I correct? Yes, this is what they mentioned. And then we can give the address of latitude, address of longitude. Oh, no, sorry. Yes, address of longitude, address of longitude, address of longitude, address of latitude, and then we can give info. And we have to compare it to see because they are saying that scanf returns the number of characters that it has read. Long, and use long. We can use lat. No, it is fine. Okay. Now what we have to do is we have to print it. So the data, how the data should get printed. Okay. So the, and inside it printf. We will display comma only when it display the previous line. Okay. So the assembly start equal to 0. Good. Then we have to print the comma transformation and else start equal to 1. And we won't print rather than what we are going to print as is this side longitude colon percentage comma latitude colon percentage comma and info colon single quotes percentage whatever we got info bracket close double quotes comma backslash. I don't think we have to do backslash because we have to do backslash above. So then we have to pass the percent of the long lat and then info whatever the information get from the percentage and address. So as soon as this while block gets executed, we will print backslash n and close this return 0. This is the correct thing which we have written. Now we have to create some sort of data, right? We can test data. We can test data the CSV. Okay. So first line, longitude T1.0, whatever, 21.2, and info is speed equal to 21. Test data, and then 20.2, comma, and percentage, comma, percentage, comma, percent minus. So how does it understand that this comma, which I'm not able to understand? JSON. Okay. 12.2, comma, it equals to equal to 22, 13.2, comma, 13.2, comma, it equal to 33. Okay. Now what we have to do is gcc gps to JSON gpj return dash o gpj gpj. Now if we execute gpj and redirect the input from the CSV test data.csv, and it prints the JSON data. But there is something wrong with the JSON data. Longitude, latitude, info. Then in the next line, okay, it only prints the value one time. So the second time, what was it? This way. So comma backslash and once again. So okay, the mistake here is first started with 0. Sorry, my mistake. Started. Now first time it is not started. Then it is started, and then this code will not get executed. Yeah. Now it is correct. Longitude, latitude, and now we can correct this code. Started for the first time. Only the first time. It's different every time. And what we can do, we can just it. Now it's fine. Okay, so what I have done is so if started, basically first time started is not equal to is equal to 0, so this condition will be false. It will make it to 1, and then it will print. and then it will be true, so it will comma and every time it, but this code block gets executed every time if we don't need it. So we could keep it in the else block, or we cannot put it in the else block. Whatever we want else block will work. So this is correct. And then what it is saying, if we want to store that data in output.json, we can then print the output.json. So it gets stored in output.json. Amazing. Yeah. So but what I don't understand is how this scanf actually works. So percentage. Okay. So okay. So this is the delimiter. That is very interesting. I always thought about the scanf can read only one value, but it seems that scanf can read multiple values. Whatever you are trying to fetch from the standard input, it can mention how you want to read that specific value. Maybe. Got it. Mount to CPJ test data CSV or GPJ test data dot CSV Amazing. So let's move on. Download the web page from map.html. This is a web page that contains the map. This is the file output.json. Decimal point is in the wrong place number. So now the next time it is saying that we need to validate the data. For example, if someone has input some incorrect longitude and latitude, if the latitude is less than -90 or greater than 90, then error with the status 2. If longitude is greater than or less than -180, let me move it here so that I can read it and print it here. So now what they are saying is, if I put it okay. Now they are saying that if latitude is less than minus 90, or latitude is greater than 90. Okay, one thing this, then error zero. And other condition is if longitude is less than -180 or longitude is greater than 180, then also they are saying return with status code 2 and return with status code 2. Okay, and they also want us to print some message. For example, printf invalid latitude, whatever the value of the latitude will be, which will be given by latitude, and same invalid longitude, and this value we will get by log. So they are telling us to do this. Okay, it is simple. Now let's do something in our test data.csv. Instead of 200, let's just compile it and run our code. Invalid longitude. Okay, so the longitude was invalid. So first we are reading the longitude and then we are reading the latitude. So it is totally fine. Now what they are trying to say here is, for example, whatever be the output of your previous program you executed, you can get that value by dollar question mark. So it is a basic. So the status code was 2. Echo. For example, now let's assume I run ls. So ls executed successfully. Now if I execute this, it will get me the output of the previous command which I executed, whether it was executed correctly or whether it was executed successfully. And we can see that my previous ls command was executed successfully, so it returned 0. But if I'm going to execute my code, then if I'm going to print this command, then it will show 2 because it was not getting executed correctly. So now let's move on forward. Wouldn't it be a dreamy if there was a special output for errors so that I didn't have to mix my errors in with standard output? But I know it's just a fantasy. But no, it is not. So this is one error, this is another error, this is single mouth, multiple uses. The standard output is the default way of outputting data for a program. But what if something exception happens, like an error, like that we observed in the previous code? You will probably want to deal with things like error messages a little differently from the usual output. This is why standard error was invented. The standard error is a second output that was crafted for sending error messages. So the purpose of standard error is only to send the error messages. Human beings generally have one ear and one mouth, but the processes are weirdly different. Every process has one ear, the standard input, and two mouths, the standard output and standard error. So we have to remember this. This is a very, very important point. If I want to remove that color, I want also remove it. So it has one standard input and one standard output and one standard error. So you can see two modes. Okay. So standard error goes here, and if there is a standard output, this goes here. So let's try to understand. By default, the standard error is sent to the display, as we can see. Remember that whenever a new process created, the operating system points the standard input at the keyboard and the standard output at the screen. Well, the operating system creates a standard error at the same time, and like the standard output, the standard error is also displayed to the sent to the display by default, just like similar to standard output. Both are sent to the if we can see display, both mounts are sent to display. But what we can do here is the standard error, if there is some sort of error, it will continue to send the data to display. But we can also do is send the standard output to a file, and that's really cool because it means that eventually if standard output is redirected somewhere else, by default any messages sent down to standard error will be still be visible on the screen. Oh, okay. So what it is trying to show here is, for example, if we are going to GPG and GPG is going to read the value from test data.csv and output.json is going to redirect to. But what happened is at output.json, no, the error message did not get. So here the error message did not get. So you can fix the problem of your item by simply displaying them on the standard error. So but here we will not able to do that. Printf. Okay. Fprintf prints data to a string. You have already seen that printf function sends data to standard output. What you didn't know is printf function is just a version of more general function called fprintf. Okay. Fprintf. So fprintf stdout I like turtle will print to the standard output. So whatever we want to print here, uh, so if fprintf and the first argument will be stdout. Okay. Now what if we execute our compile the code and then execute the standard output. Okay. So it is saying then what we can do here is we can print this automatically prints to standard output and standard out, and rather than using it here as printf, and here we can std err, and standard error by default displays to, as we know, std err output of std by default it prints to. So exception is getting printed here, and if we say output of this, whatever being converted is converted here. Okay. This means that the code should not work in exactly the same way, except the error message should appear in standard error instead of standard output. Let's run the code and see. Invalid attitude. You recompile the program. That's excellent. This time, even though you are redirecting the standard output in output.json, the error message is still visible on the screen. The standard error was created with exactly this in mind, to separate the error messages from the usual output. But remember, stderr and stdout are but just output streams, and there is nothing to prevent you from using them for anything. Okay, the printf function sends data to standard output. The standard output goes to the display by default. You can redirect the standard output to the file by using greater than on the command line. Scanf reads the data from standard input. The standard input reads data from keyboard by default. You can redirect the standard input to read a file by using less than sign on the command line. The standard error is reserved for outputting error message. You can redirect the standard error using the 2 greater than sign. Oh, okay. This is amazing. So we can use the 2 greater than sign to redirect the standard output. So if we want, if there is something error, 2 greater than err dot log. So cat err dot log is the error. Okay. Let's do greater than. We can comment here greater than scanner less than less than, and for err we can use 2 greater than. So if we want to redirect PD err, we can use 2 greater than. That means we are using GPG test. We are reading standard input from test data CSV. Then we want to err the log. There is some error. Immense. Okay. So this is fine. This is something we are going to default thing we are going to discuss. So I think this was enough for today. We are able to reach page number 128, and I think I should stop streaming here, and maybe where we have reached here we have reached. Let's see, standard error, more tools are flexible. So tomorrow we will be able to complete this chapter, and then we will go to using multiple source files, breaking down and build data. Then there is some CLab, and I think within a month we will be able to complete this book. I would say that we will become a great C programmer after reading this book, but I think we have learned a lot of concept and amazing concepts with practical use cases, rather than reading some old school book that is very difficult to grasp and difficult to understand the concept. This book is amazing, and there are also other books, other concepts on which these headfirst books are written, so you can go through them. For example, Java, object-oriented programming, design patterns, and networking. So you can go to those books also. And these are amazing books to learn, because they give you some sort of practical use case and then try to teach the concept, and that is very engaging. Okay, thank you everyone.